Hello, hello, hello. I hope you're well. Another 2 weeks in lockdown. How's it been for you? Have you been okay? Are you keeping safe? Are you well? I hope it's been all right for you. I think it's a bit of a struggle for all of us to keep going. But what can you do? At least you've got school to look forward to, so that's something. But hopefully this will be done in a few months' time. Who knows? And we could be back at school before too long. So let's hope so. Please say hello in the comments. Be great to greet you and say hello. I'm going to stick to my plan and do half an hour today. I know you've all had lots to do today at school, so I thought I would just stick to half an hour and get through as much as I possibly can. So please say hello in the comments, and I can know who's here. All right, so today's plan is as follows. We're going to talk about system software. Hi, Luke. Hello, James. Nice to see you. I hope, are you chaps all right? How's the week been for you? It's Umar. How are you? Good to see you, old boy. I hope life is treating you well. Not much is new for me. I've had a new PlayStation since we last met. That's the most exciting thing that happened to me, other than preparing for this. So there we are. I hope you are coping well. Well, let's get on with this and see if we can get it done in half an hour. 31. So only 1 minute wasted so far. System software. This bit is actually quite straightforward. So let's see how much you know. I've tried to make this as quizzy as I possibly can to try to make it slightly more engaging for you. So system software, or utility system software as it's known. So this is the other half of you've got the operating system software, and then you've got this sort of utility system software we're going to look at today. So in the comments, I think last time we covered this, system software allows a computer to, and what do you think that might be? What could you put in the comments there? System software allows a computer to what? Any ideas at all? Breathe? Not much in the comments. Okay, I shall push on. It allows a system to run, to be maintained, and to multitask. Those are the fundamentals of system software. And obviously some of those are to do with the operating system, and some of them are to do with the utility software that we're going to cover today. I hope you can still hear me, because it's all gone quite quiet in the comments. Do say hello. I think there are 7 of you currently lurking. Just do say hello and introduce yourself in the comments. Let's see how it goes. Right, so let's push on. Utility software. Modern operating systems have got a range of programs, a range of these utilities as they're called, and they do useful things. E-man, hello. They keep your system secure. They keep your storage disks organized, and we'll get onto the disk defragmentation bit later on, and they maintain the system. And this keeping your storage disks organized, when we get to that part, people are generally quite strong on encryption. They know what encryption is. They can describe it quite well. When it comes to disk defragmentation, easy for me to say, it's one of those areas that people seem to not quite understand. So I think my main aim today is that at the end of it, you've got your heads around all of these areas, but also the disk defragmentation, which, by the way, you don't need to do on solid state drives, but we'll get to that later on. So they're called utilities. This from the specification. They want you to know about encryption, defragmentation, data compression, and that's the whole lossy versus lossless thing. JPEG being a lossy file, and WAV being a lossless one. Same as AVI being a lossless form of video, and MPEG-4 being lossy. So some information chucked away, but still good enough, and gives you great download speeds. And then we'll look at backup, something that they have popped into the exam, and we don't know whether we're going to get any little mini exams. We still don't know that. So no further news on that. But that's the last part, is this idea of backup, backing up your data in case of data loss. So fill in the blanks. Encoding information. We're talking about encryption here. Encryption is encoding information by converting what into what. I really hope there's something going to come in the comments here. Encoding information by converting what into what. Any ideas at all? Converting what into what? Ooh, public text into cipher. Umar, you are very, 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 very close. In fact, that is good enough to be right. Good man. So it is plain text into ciphertext. So that is I've tried to really narrow this down into just the nuggets of information that you need. You know, when you look at the mark scheme after you've done one of your assessments and you realise they only want a word or two, converting plain text into ciphertext. That is the definition of what happens when something is encrypted. Okay, next one. It renders information something. It's got a U and an E. So it renders information if... And by the way, it's not actually a rude word that goes in there. It starts to sound like a rap song, but it renders information something if something. And this is kind of why people do encryption. Bonus point, by the way, if anyone can tell me what is the network threat which could lead to data being stolen. Anyone know the name for it? We've got two names. See if you've been doing the amazing videos that I've been sending you. I'm only biased because they take so long to make them. Any ideas? Renders information something by if something else. Anyone got any idea on that at all? I'll give you a minute or two. Ooh, unreadable intercepted man. Luke is on fire. I mean, I hope not. That's not a literal thing, but it does. It renders information useless or unintelligible if intercepted. Absolutely spot on. And that is the key thing. That's what it's all about. That is what happens when you encrypt. Is that, I mean, there's a caveat here, is that if someone had all of the computing power in the world, you can break a cipher, but it can take so long to do that it's practically pointless. So it's rendering information unintelligible if it's intercepted. That is why people want to encrypt. Now, this I'm going to whiz through at some degree of speed because I assume that you know this. We talked about it being scrambling data. If it's intercepted, it's unreadable. And by the way, Luke, yes, it was the man-in-the-middle attack. Data interception, man-in-the-middle attack, that is the threat. And the way that you would mitigate against that threat is by scrambling the data, encrypting the data. So encryption software, and that's where it comes into utility software that we're talking about. So how does it work? An encryption key is used to convert plain text into ciphertext, and that was Umar's excellent answer earlier. So how does that work? So the encryption key it's an algorithm. It's actually a long string of letters and numbers, which is used to alter each piece of data in a file. And obviously the simple one that everyone knows about is the example there, which is the Caesar cipher, where you can move each letter in the alphabet one shift left or one shift right. So hello world becomes ifum, and that's how it works. Obviously that would be a rubbish encryption method to use because it's very easy to break, but it gives you an idea of how it works. Now, I had a feeling that it would be you guys here today, so I've got a slightly more complex way of looking at this, which is a little bit more kind of 7, 8, 9 in terms of grades, but I think you might appreciate that. And of course, the other side of this is that then to put it back into plain text, the same key is required by the recipient to reverse that encryption, so you can reverse the process of encrypting the data. All right. So let's have a look at encryption. And by the way, I realised, having put this image up there, that you've got two sorts broadly, and I'm going ever so slightly beyond GCSE here, that you've got symmetric versus asymmetric. Now, symmetric would be a mirror image. You get the same on both sides, which is what I was trying to achieve with that rather unpleasant looking sort of stairs there. But you've also got asymmetric, and that's where it comes into the public key and private key that we looked at in the past. So let's look first of all at symmetric encryption, and that's where there's one password which encrypts and decrypts. So if you want to do symmetric encryption, it means that you've got to give the recipient the key to unlock it. And when I say key, I mean this idea of a password, an encryption key. And we know that the encryption algorithm, it's a long string that's used to decode and to change the contents of the message. So that's the issue. Same encryption key is used to encrypt as to decrypt. The issue is it's less secure, because if you think about it from a physical point of view, the password's got to be sent to someone for them to decrypt it. Now, we do work with social services, and they will send us a password-protected document and then send us an email with the password afterwards, which if someone's actually intercepted the first document, then it's the most lousy way to try to keep things safe, because actually then the next document you get sent is the password. And it's funny how it was a version of that actually led to the Enigma cipher being one of the ways in which it was actually discovered. So that's the problem, is that if you use symmetric encryption, you've got to send someone the key, and you do that over the internet, then you're taking risks, aren't you? Because it can be intercepted. So then we come on to the asymmetric, which this is the public key, private key that we've looked at before. So the idea is that you could have many keys. You've got one key to lock it and one key to open it, and they're different keys. And that's where you've got this private key versus public key. One password to encrypt and one password to decrypt. And this works by having a public key and a private key. The public key, again, long string encryption key used to encrypt, but the public key can be shared with everyone. The private key, again, a long string, that's only owned by the recipient. So the recipient uses that to unlock the box and to get at the message. And why is it more secure than symmetrical encryption? Because you don't have to share your private key. So therefore, it's a really fabulous way of encrypting. And obviously, governments are very keen for software designers like WhatsApp to build backdoors into their product, but they have as yet, and as far as we know, refused to do so. So they're not actually able to read our messages. It wouldn't be very exciting reading mine, but that's where we are at the moment. World governments aren't very happy about doing it. In certain parts of the world, it is illegal to encrypt your messages because the government can't snoop. All right. Ooh, we've got a little quiz for you here. Encryption utilities can also be part of the what? Answers in the comments, please. Oh, blimey. I was dozing, Luke. It's the operating system. I thought that was slightly more tricky. Part of the operating system. They can. I've gone for a fill-in-the-blanks approach today. We've gone for a language teacher approach today. So encryption utilities can be part of the operating system. So some of these utilities they're talking about, they come bundled with Mac or Linux or OS X, and some of them you buy in, but they are still utilities which are designed to, in some way, improve the running of the computer. That's broadly what they all do. All right, now this is I'm doing a kind of a bit of a backstory here, because before we start talking about defragmentation, you need to understand about what happens when a disk is formatted, because otherwise the story makes no sense. So bear with me. OS not so. What do you get with OS? You get you do get some stuff. You get a disk utility with OS. Faraz, remind me. I should know because I use OS X myself. And you know what? They talk about encryption utilities. I've not owned a copy of Windows for quite a while. Do they give you an encryption utility with Windows? You definitely get the disk defragmentation, and you get a disk utility, but I'm not sure. I mean, there is a firewall bundle with it, which you could argue is part of that. Anyway, let's get back to the story. Formatting. So formatting is when you wipe a hard drive. So if you were selling your computer or sticking it on eBay or whatever, you would wipe your hard drive, and it's called formatting. People call it wiping or trashing their hard drive. Hi, Path, how you doing? Glad you can make it. So we have, let's have a look. We've got 10 people in at the moment, which is good. I think it's really impressive that having done a day of Zooms, goodness knows whatever else, you find some time to do this. So I'm really pleased to see you. Okay, back to the story. Formatting is when you wipe your hard drive. When you wipe your hard drive and you format it, sectors are created, sectors and tracks, and it's on these sectors and tracks on which data can be stored. Now, at the same time, and I'll talk a bit more about sectors and tracks in a second, okay? But at the same time, the file allocation table is created, the FAT. And if you've ever mucked around, yeah, I'm good, Path, not bad. I'm looking forward to half term. I mean, there's anything to do, anywhere to go, but somehow, I don't know, I might just get a bit better at World Rally Championship. I'm quite enjoying that. So the file allocation table produces, it's like an index. It's not like an index. It is an index which keeps a track of all of your data. Have you ever had that experience when you're using your computer, and this is across all operating systems, and you get a little message saying indexing, and that means that the file allocation table is being reorganized or being sort of is being put back into shape. So the file allocation table keeps a handle on where all Naveen, this is so try the end of this week, and if that's not the case, this is going to be the shortest live stream in the world, because I'll just go away and cry. So the FAT table is used to keep track of where the data is, right? So when when you format your hard disk, the FAT table the old FAT table is destroyed, and a new FAT table is written, FAT, which keeps a track of where all the data is. So that kind of leads you into something quite interesting, because you quite often see on the news that it says that the police can recover data from a hard drive. And the way that's possible is because when you format a hard drive, you don't actually delete the data on the hard drive. You just delete the file allocation table. And of course, the file allocation table is what's used by the OS to open and find a file when you want to look at something. So even though it can't find it and it says that it's been deleted, it's actually still on the hard drive until you overwrite it. And if you go and look at ways of really permanently deleting a hard drive, the safest way is to take a sledgehammer to it. The second safest way is to write random binary, and you can do this within the yeah, exactly, that overwriting it 35 times. And what you're doing, Faraz, is you're writing ones and zeros over it repeatedly, so that ultimately nothing can be found. So you can go and buy some software to actually recover stuff off a hard drive. I had a go when something vanished, but it's a bit hit and miss. So once the drive is formatted, you've got a new FAT table, and therefore all the data that's still there is simply regarded by the OS as free space. So it's just written over. Yeah, that makes sense. So that's the backstory that you kind of need to understand to get this next bit, which is the defragmentation software. So let's get through the computer sciencey bit. When you format the disk, sectors are created to store the data. I don't know whether you can see in the a zip bomb. Tell me more. What does a zip bomb do, Naveen? Get onto Google. Give me a definition in the comments there. When a disk is formatted, sectors are created to store the data. I was going to say, if you look at that image on the bottom right there, can you see these tracks and sectors? And the tracks are a bit like railway tracks, except they go around in circles. And the sectors are sort of segments of that track. And so these are sort of created as areas to store data when the disk is formatted. Now, in each sector, 512 bytes is stored. So that's the first thing, is that actually it's a very small amount of data that's stored in each sector. Now, when a file is stored, it's like a RAR file that's only a few kilobytes large. When you extract it, it will be like petabytes, terabytes. Oh, okay. And basically, okay. That's interesting, Naveen, because that's kind of it along the same principles-ish as a worm. You know, the stuff we've just done on worms, that worms just basically throttle the life out of your computer, because they end up just creating so many files and and they just take up so many resources. Did you look at the figures around the Stuxnet worm when it was released? It was just insane that after 3 minutes, it had managed to get inside hundreds of millions of computers. It's incredible, absolutely incredible piece of code. I mean, random, because if people release viruses all the time and most of them have very little impact, then you get the odd one which just completely takes off. But again, it was just done for the sheer hell of it to see what it did. Right, let's get back to the story. So we've got these 512 byte sectors. Possibly, Naveen, but now you're starting to scare me. I might have to get off this sooner rather than later. So each sector, 512 bytes, quite small. So you've got these blocks, right? But a file isn't stored as one block of data. It's stored as lots of these 512 byte blocks, and they're not stored together. They're stored wherever free space is available. So one file can be stored in many different physical locations across the hard drive. So the issue is that over time, as your hard drive gets more and more full, these blocks get fragmented and dispersed over the entire hard drive, which means that the read-write head, which is the second picture I've got there, the one which is obviously a read-write head on a hard disk drive, it takes longer because the hard disk drive has got to go in many locations to actually open the file. I hope that makes sense to you, which if you get that, then the need for defragmentation becomes absolutely obvious, because defragmentation is going to move all of these sectors together so that, you know, a given file, all of the data required in these sectors is moved physically together, so the read-write head has far less to do. So it's just sending a worm to a teacher. Oh, for a teacher, you'd probably be paraded around the streets, to be fair. Although now that students have been at home for yeah, it does. If you get caught, this is so true. It's not the crime; it's getting caught for doing it. I was going to say, I think parents have probably got a bit more time for teachers now. They've had to deal with their own kids for the last year. That's how long you've been at home for. Won't last long though. Right. So does that make sense about defragging? Defragging means that you're going to move these blocks next to each other. And that means that the read-write head has got less to do in order to open a file. There wouldn't be much point in stopping you coming to school now, would there? I mean, I suppose they could spite you by bringing your grades down, but pff. All right, here we go. This is a question for you. I've got a feeling I've got too many blanks in here, but let's give it a go anyway. Defragmentation utilities reorganize files on a... to put the fragments back... I reckon that's just ludicrously easy, but could you simply put do this question for me, but could you put in the comments either a simple yes or no as to defragmentation? Does the story make sense? Drive is formatted, sectors and tracks are created. When a file's stored, it's stored in little 512K little lumps, little blocks, and those blocks are actually stored in the next free position, so they won't be next to each other. So defragmentation puts it all together. Hard disk drive together. Ooh, let's have a look. Hard disk. Ooh, that is so good. Have a quire. That is absolutely fantastic. That is outstanding. So let's put that together and have a look at this one. It was defragmentation. It is reorganize files on a hard drive to put the fragments back together. So this idea of fragments, okay? So the important takeaway here is that when a file is stored, even though on your OS it looks like it's one file, it's actually lots of fragments that are spread all over the hard drive. Brilliant. Okay, so this reduces movement of the across the that speeds up the... All right, I promise you, I won't press the beep button again, but good. I'm glad that makes sense, because it's when I've read assessments on disk defragmentation, it's clear that people don't actually get it. And I figured out that if you don't know how or why a drive is formatted, then you can't possibly understand disk defragmentation, because it's illogical to defragment a drive if you don't know how the data on it is stored. So this one reduces movement of the R. Well, you can read it for yourself. Across that speeds up the... Any ideas as to what this would be? Any ideas at all? Whatever you do, don't keep John Travolta waiting, because he just doesn't like it. Oh, hello. We have got Luke who's saying read write head across the disk and the read speeds. It is absolutely correct. So that is outstanding. Let's go on to the next slide. And let's get rid of John Travolta. This reduces movement of the read-write head. So the read-write head has a lot to do, and you are giving it less to do if you put the data that it needs physically next to each other. It's got less far to travel to find the data, and it speeds up read speeds. It will speed up write speed as well, but fundamentally it speeds up read speeds. Umar, read-write heads, yes, you're absolutely spot on. That's good. I'm glad that's making sense. Okay, I think I mentioned this at the very start, but just you should know this in case you ever tried doing it. It's unnecessary to defragment. Okay, I lied about the beep, maybe, but it's unnecessary to defragment what? What don't you need to defragment? Any ideas? Yes, solid state drives. More correct answers. Who's that? That was Naveen, straight in there. What a good man you are. Solid state drives, yeah. Why? Because they're so quick, there's no point. And why? Because it damages them. I don't know why it damages them, but it shortens their life. And I'm guessing, yeah, that's all right. It was spot on. I'm guessing that for the same reason that, you know, when solid state drives are used as RAM, what's the word? Virtual? Yeah. Then when they're used as RAM, it really wrecks them very, very quickly. That was impressive, I've got to say. 104 words a minute. That is very, very good. That's outstanding. Okay, defragmentation puts them towards the end of the disk. Oh, I just gave you that one away. I need to speed up because this is taking too long. So defragmentation, yeah, virtual memory, good man, Umar, that's exactly it. Let's give you a quick... and I think that we can just say that Umar... Yes, you can! Good man. So that's what defragging does. It puts up the fragments, puts them together towards the end of the disk. I'm going to need to speed up, actually. Defragmentation speeds up... You know, on this live stream, I've set the latency to ultra low, but it seems that whatever you do, it just takes blinking ages, whatever you do. But anyway, yeah, you guys know your stuff. Umar, Naveen, virtual memory, that's really, really good. Yeah, it does free up storage. That's absolutely spot on. The actual answer I was looking for was space, but you've pretty much got it. Also, SSDs are random access like RAMs at the same speed as any other drive. Absolutely spot on. They are, Umar. That's a really good point. Let's give you a little for that. Absolutely spot on. Umar's comment is absolutely correct. Do you know something that SSDs that's a really negative thing is that if you have an old sort of hard drive, a magnetic hard drive, you do get some warning of when the thing is coming to the end of its life. You get failures, but you can get it back up again, and you get a bit of warning. With a solid state hard drive, when it goes, the solid state hard drive went on my Mac at home, and it was just like switching a light off. It just went, and that was it. And I couldn't get anything off it. All the data was lost. Back up your data. Okay, let's whiz through this one. I think you guys know this. Yeah, Naveen, space storage, you're absolutely right. So compression, we know you've got two sorts, okay? You've got lossy and you've got lossless. But why would you need to reduce the size of a file? I know that you know this, but it's one of these areas people chuck away marks in tests. Why do you want to reduce the size of a file? Because you need less storage space, because storage is expensive. There's 2 marks there. Why? Because you get faster download times and you get an improved online experience. You get faster streaming speeds of video and audio. By the way, I'll make this available to you, what I'm using here. So compression software reduces the size of files in 2 ways. You've got lossy and you've got lossless. We know that MP3s and JPEGs are the lossy side, that it chucks away data, the unnecessary data, to hit that sweet spot where the music is still, yeah, it's one of those things, you know, I don't get too het up on whether it's a Mac or a PC. Overall, for what I do, it's probably a better bet, 'cause I do a lot of video, I do a lot of audio, I do a lot of photography. They last a bit longer, They're more expensive, but they're just a nicer product. But for gaming, you wouldn't go near one. So you chuck away unnecessary data, and it hits that sweet spot of the quality being good enough, but still the file size is nice and small, like MP3s that you can have thousands on your phone. But if you go for the full size lossless audio file, they take up an awful lot of space. So then you've got this lossless compression. I've got that thingy of WinZip on the left-hand side there as my nod to Windows, because that was the first one that I came across. So this is where data is temporarily removed from the file, but it gets put back in when the file needs to be used again. But zip files have got to be extracted to be usable. And zip used to be a lot more popular, but zip only, it brings file, it varies. And there are different algorithms within sort of zipping, but they generally don't reduce the file size by a massive amount. Not as much usually as lossy compression. Okay, compression utility is reduce the watt of a watt. I imagine, well, I don't want it to melt on my desk. It was enough of a bad shock to have to replace the hard drive. But when you think about it, so many of the components across Macs or PCs, it is the same componentry. One of the things I do like about Macs is you've got the same company making the OS as making the hardware, or is putting the hardware together. I shouldn't contradict myself. The new M5 chip looks like they have kicked Intel right. Yes, thank you, Luke. You're absolutely spot on. Ooh.
Yes, you can.
Yes, you can, and yes, you did. Compression utilities reduce the size of a file. So compression ensures that files take up less space, and it's quicker to download over the internet. You didn't really need to tell you that. That is all we need to do. I'm going to whiz through these because I said half an hour, and I've still got another 10 minutes to go. So if you do need to push off, I will understand. So compressed files, I think the E word is one that you need to know. Can anyone think what that E word would be? The E and the R word, that is kind of important. Yeah, but it seems like, Naveen, the M5 chip that Apple have just come up with is significantly, has moved the game forward significantly, and in a way that it's as though Intel have sort of taken their eyes off the ball completely. Because it was just Intel and AMD, really, it's been that way for a couple of decades. Extracted and read. Blimey, Luke, I need to look at my screen more quickly. That is outstanding. It is extracted and read. Compressed files got to be extracted before they can be read. Absolutely spot on. Next one. If data is lost during the compression, the quality of the file is... What happens to the quality of the file? It is, and again, all of these are obvious things that when you look back at your questions afterwards, you go, yeah, well done, Darren. Hi, Darren, and nice to see you. It's so easy to chuck away marks. Reduced, yes, reduced. Well done, Darren. That's outstanding. You can have the choir singing to you. Let's get rid of the choir. Right then. Oh, this is nice and big. D is TL using. I don't know. Hi, Darren. I hope you are well. I hope things are going well for you, and you're all keeping as sane as can possibly be achieved with all this all this incarceration at home. Any idea on this one? D is TL using the WinZip. They're not going to talk about WinZip, by the way, in any tests that you have. They're going to talk about lossy versus lossless, all right? And the idea that it's an algorithm that reduces data not lost. Who was that? That was Umar. Umar, that was fast. That was super fast. Data not lost using the WinZip utility. Brilliant. Okay. We are getting to the end. I'll be done here. Data not lost, WinZip. Yes, Faraz, you're absolutely spot on. Let me give you guys some of that. That's all exceptionally good. Right. Yeah, actually, we've caught up time. So backup, really easy peasy. Obviously, backing up, you back up data so that you don't lose it. And we'll look at reasons you can lose it in a second. But you've got, I love this word mitigate. So making a copy of files to mitigate against data loss. And I know I'm being pernickety here, right? But you can't prevent data loss because you still lose the data. And even though you've got a copy of it, you've still lost it. No, I'm just being picky. But you can mitigate against losing data in two types of backups. You've got full and you've got incremental. So let's look at these. Why does data get lost? I love my last one there. It's because you lose it. I don't know whether you guys got as far as watching the video where I was talking about people, secret service agents leaving USBs on trains, which has happened countless times, giving away. Do you know that was the plot, or the start part of the plot in Skyfall? So yeah, couldn't believe it, could you? So how can you lose it? Data can be corrupted. Data can be corrupted just by using a computer. In any day-to-day work with a computer, data can get corrupted. You've got malware, you've got deleting things accidentally, you've got data being stolen, you've got a hard drive failure, which has happened to me. And oddly enough, I rather arrogantly thought that it wouldn't happen, and it did, and I lost my stuff. So back your data up. So let's now look at the two sorts of backup you've got. You've got full and incremental. Full is very easy to understand because you back up every file on your system, and every file is copied and saved elsewhere. Now, in somewhere like a school or a business, you're going to run incremental and full. But your full backup, you're going to store in a fire safe off-site, so that if the building burns down, if it's blown up, if it gets flooded, you want to make sure you've still got a copy of that backup, which is not reliant on being in that building. And then we've got incremental. So if you imagine that you do a full backup at some point, if you run an incremental backup, only the files that have been changed since the last full backup are copied, or since the last incremental one are copied and saved. So in theory, you could go back through lots of incremental backups until you get to a full backup. You could do that. But equally, why do they have full and incremental? Because one takes a long time and one takes a much shorter amount of time. And obviously doing an incremental backup, you're only saving the changes that have happened since the last backup. Doing a full backup requires, could require saving petabytes of data. And most companies will use a combination of these, and perhaps they'll do a full backup once a week and they'll do an incremental backup daily. I mean, I'm making that bit up, but that's the sort of picture, the sort of way that this would be done. This is too easy for words. I'm aware that I've gone 7 minutes over. Data is not lost. Yeah, we got that one. Backup utility will take a copy of file to mitigate against, and I'm looking for, do you know what? I can see it in your answers because Luke and Faraz have talked about it. Umar's talked about it. It is obviously data loss. Data corruption, yeah, it'll do that as well. Data loss, data corruption. We're talking about because once data is corrupted, it is effectively lost, isn't it? Because you can't do anything with it. And I think I can count on the fingers of one hand the times that I've managed to get anything back that's been corrupted. Ta-da! We have done it. So that's outstanding. 38 minutes, not bad at all. So next week, the plan is going to be legal, ethical, moral, and environmental. This was from the exam marks. I'll try that again in English. This was from the exams that I marked. An area that it was as though none of you had ever been taught it at all in any shape or form, because the answers you provided for this bit of the exam were, what's the word I'm looking for? Dreadful. They were dreadful. So that's going to be the next thing that we'll look at. And I think the issue was constructing a longer essay-style answer, which is not something you've got to do that often in computer science. But these sort of big 6-8 mark questions, you need to absolutely nail. And quite a few of you threw away marks on that. So that's what we're going to look at next week and the week after. It only remains for me to say thank you very much for coming along. It is great that so many of you did. I will make a copy of this and I will put it onto YouTube, and I will make the presentation available to you. Have a lovely week, and I will speak to you all soon. Goodbye. You're welcome, Darren. You're very welcome. Have a good week. Take care. See you guys. Bye, Flaming Eagle. Flaming Eagle. Bye, Luke. Enjoy the sound effects. Yes, I was. Yeah, I do like my Stream Deck. It's a nice toy. Bye, Umar. Have a good one. Path, if you're still there, cheerio. Darren, see you later and have a good week, guys. I will speak to you soon. Take care. Bye-bye, Umar. Cheerio. Bye-bye.